All right, you guys, this is our last official lesson for the polar unit. So we're going to continue converting equations today, but this time we're going the other direction. So we're starting with polar equations and we're going to convert them to rectangular, meaning it will have x and y when we are done. Last time we wrote out the formulas, but I thought it'd be a little easier to have them printed for you already. So again, just reviewing the formulas that link our four variables together. You can see them all in this box on the left, and then you have your image showing how they're connected on the right. The ones that we're going to use are pretty much the ones in the right-hand column of that box. Those are our four main ones, and then this one right here we'll use a little bit as well. The other three kind of help us get these four equations that we circled, but we primarily will use these four. So remember, the big idea here is we can swap anything that's equal to each other, right? So I can replace an r with square root of x squared plus y squared and vice versa. That's how those are helpful, okay? So let's just jump right into the examples today. So again, we're converting from from polar to rectangular. So that means that we need x and y when we are done. We want everything to be in terms of x and y, and we don't want any r's or thetas left over. Our other key here is that our rectangular equations will be circles or lines. So it's a little bit trickier sometimes to know when you're done simplifying for rectangular equations. So for circles, we're looking for something like x squared plus y squared equals a number like 49. That's a circle equation. Sometimes we'll have to complete the square. So like x squared plus y minus 3 squared equals 16 is another example of a circle equation. And then our line equations, we can have x equals a number, y equals a number. Those are pretty much the ones that we'll see today. Just our regular vertical and horizontal lines. Right, so let's start with our first example here. So it says change r equals 6 to a rectangular equation. That means I want to replace r with something that has x's and y's. Now looking back at the equations, that very first one here will work. So I can replace r with the square root of x squared plus y squared, still equal to 6. Now I don't want to leave that square root because it doesn't really look like a circle equation we're familiar with. So I can get rid of it by squaring both sides, leaving me with x squared plus y squared equals 36. That's a nice circle equation, centers at 0, 0, radius of 6, and I am done. Our next example here, changing r cosine theta equals 5 to a rectangular equation. So r cosine theta sticks out to me right away from those formulas at the top. I know that that is all equal to just x, right? Those are interchangeable. So here it's x equals 5, and this is already a vertical line equation, so I'm done. Pretty easy. Next, we have r equals 6 cosine theta. Now, this kind of looks like the one we just did. The problem is this right side over here. I don't have the r because we know x is equal to r cosine theta, but I'm missing this r. Okay, so one thing I can do to introduce that, we might want to make a note here. We'll multiply both sides by r. Okay, I can't just interchange anything yet because I don't have anything that's actually equal to each other from the equations in that initial box that we started with. Okay, so I need to get an r on the right side. To do that, I'm going to multiply both sides by r. So now my equation will be r squared equals 6r cosine theta. Right? I can change the order of the multiplication so it matches the formula I'm used to seeing. I know that r squared is the same as x squared plus y squared without the square root. And I know that r cosine theta is the same as x, so I'll have 6x. Now this one can be a little bit trickier to simplify. here we will complete the square. Okay, remember back last semester and in Math 3, we would simplify circle equations, or convert them, I should say, by completing the square. So what I want to do first is move everything to the same side. So I'm going to subtract the 6x. So now I have x squared minus 6x plus y squared equals 0. Now I'm only going to have to complete the square with the x variables because there's no just y term. So I have x squared minus 6x plus a blank, still plus y squared equals 0 plus blank to keep it balanced. Remember, to figure out the missing blank here, I take the middle term, 6 divided by 2 equals 3, then square it, which gets 9. Add it to the other side. These three terms right here, this is a perfect square trinomial, so that can be factored, or kind of the quick trick. X first sign is negative, so it'll be minus half of the middle term, so 3. Half of 6 is 3. Squared plus y squared, 0 plus 9 is 9. This is a circle equation we're familiar with, so I know I am done. A couple more examples here. Okay, so this time I have a different trig function. I have a secant, and we know none of those equations from the beginning have secant at all. So I'm going to use one of the identities from the last unit to change that. I know that secant is the same as 1 over the cosine of theta. Those are reciprocals. So I'm going to replace it with 1 over cosine. Remember, it's multiplication there. 7 times 1 over cosine. I can think of it like 7 over 1 becomes 7 over cosine theta. Okay. Now, I still don't really have anything that would be helpful to replace. I could replace r, but then I'm left with this cosine, and that doesn't really help me. So what I notice here, since cosine's on the bottom, if I multiply by cosine on both sides, these cosines cancel out. The left side becomes r cosine theta equals 7. R cosine theta is equal to x from the top. So I have a vertical line, x equals 7. And I'm done. Our last example, I'm going to get you started and see if you can finish it. So this is similar to example 3. I almost have an equation here I can use, but I'm missing that r. So I'm going to multiply by r on both sides. R squared equals 8 times r sine theta. At this point, I want you to pause the video and see if you can finish substituting, and then you'll have to complete the square for this one as well. And I'll answer for example 5. So I substituted r squared and r sine of theta. I got all the terms on the same side, and then I noticed I needed to complete the square to make it look like our normal circle equations. So I completed the square for the y variable. When I factor y squared minus 8y plus 16, that's a perfect square trinomial, leaving me with y minus 4 squared. Final circle equation is here, and I am done.